Another example of impulsive force or impulse of a force is the jumping pit. Suppose a long jumper is coming and jumping to a concrete floor. So his momentum suddenly changes to, when he stops, the momentum suddenly changes to zero within a short interval of time. Then the force exerted will be delta P by delta T will be more. Then he hurts more. Suppose he is jumping into a sand pit, a heap of sand. He is jumping there. Then his legs are piercing into that heap of sand. So his momentum reduces by taking a larger interval of time. So when you are calculating the force delta P by delta T, since delta T is more for the same delta P, it will be less. So that person is hurting less. That is another example of impulsive force or impulse of a force. So from our daily life situation, I already told you when we started with this chapter, I already told you the concept or examples that we are taking in this chapter, particularly in this chapter, are very familiar to you from your daily life situations. Okay, so that is impulse and impulsive force that we have derived from the second law of motion. So we have seen the first law of motion and second law of motion. Now we can go to third law of motion. What is third law of motion? Third law of motion states that for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. It says that every force in the universe acts in a pair of action and its reaction. Action is a forward force and the reaction is its backward force in the same magnitude. But even though the third law says that if it is a balanced, for every action there is an equal and opposite reaction, automatically we think about if there is an equal and opposite forces acting, they will make a system of balanced forces to equal and opposite forces. So they will cancel off. If they cancel off, nothing can be changed according to the first law of motion, because first law of motion says that state change is possible only with the help of unbalanced forces. But third law says that every force in the universe is a system of balanced forces. Do you agree with these statements? Both the statements are given by the great scientist Isaac Newton. So if you are agreeing with the first statement, then you have to deny the third one. Or if you are sticking with the third one, then you have to deny with the first statement. With which one you are staying? You have to stay with both. Because in third law, he says that for every action there is an equal and opposite reaction. But he didn't say that both the action and reaction are acting in the same object. Suppose two objects are there, A and B. A is exerting force on B, that is action. B is exerting the same force in A, that is the opposite direction, that is its reaction. Action is acting on B by A and reaction is acting on A by B. Since both the force, action and reaction are not acting on the same object, they will not cancel off. So you have to agree with both the statements made by Newton. So that is action-reaction pair. Action-reaction pair will not make a balanced force since they are not acting on the same system. So that is the third law, that is law of action and reaction. For every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. Newton's third law of motion, for every action there is an equal and opposite reaction. This is known as law of action and reaction. Action will not cancel reaction because they are not acting on the same object. They are not acting on the same object. Examples of this third law: walking on the ground. While walking, we are exerting force on ground and the ground is providing equal opposite reaction on your feet through which only you can walk. Walking on sand is difficult, or sluggy area is difficult. Why? Muddy area is difficult. Why? Because if you are applying force on the ground is unable to provide you the same reaction to your leg. That is why you can't easily walk on such a floor. And swimming, while swimming, the person pushes the water backwards, the water pushes the swimmer forward with the same force. That is the reaction. Then jet planes and rockets. Highly compressed hot gases escape from the nozzle with very high speed in the backward direction. Gas exerts a reaction force on the jet plane that enable it to move in the forward direction. Again, action, reaction. Then when you are firing the gun, while bullet is moving out, it is exerting a reaction force on the gun that is known as recoiling force, recoil of a gun. As we fire, the gun moves back for a shot, and that is recoil of gun. And all these are illustrations of third law of motion. You find all these three laws of motion are very simple statements, and their illustrations are very simple, and no such great derivations are there. Derivations are also very simple, and only one derivation we have seen now, that is force equation, that you have already learned from your lower classes. So we have defined all the three, and some extra content we have to discuss from based on these three laws of motion, that we will continue in the next class, and we will meet in the next class. Bye.